Hello everyone, this is Poornima Deepthi working as an assistant professor in the Department of Electronics and Communications, MLR IT. Today's topic is Physical Memory Organization of 8086. This video is a part of Microprocessors and Microcontrollers series. So for better understanding of this topic, you need to refer the memory segmentation of 8086 in the previous videos. So coming to this video, today I will discuss about what is the physical memory organization of 8086 and how to select the odd and even memories and how to calculate the physical address while giving the instructions or program. So coming to the physical memory organization. So why this physical memory organization? As already we have seen the memory segmentations, how the total memory of 8086 1 MB has been divided into the 64 KB each segment of 16 segments, and out of these 16 segments we have been using only 4 segments at a time, that is code segment, data segment, stack segment and extra segment. So then what is the purpose of having physical memory in 8086? The total memory which is supported by 8086 is 1 megabytes. So 1 MB memory. So out of this 1 MB memory, it has been divided into 2 memory blocks, even memory block and odd memory block. Each of it having 512 kilobytes of memory. So to access, processor need to access even and odd memory blocks. That's why it has been divided into 2 memory blocks. Then what is the need of having odd memory and even memory? Here actually the microprocessor memory will be accessed like this. So if we are considering this is a memory, so if we start, the memory is starting from 4 zeros and it will end at 4 F's maximum. One block of memory, like 64 KB of memory. So the memory address which is of even is considered as even memory blocks, and the memories is always consecutive numbers like this. So to access, if we are storing like in this example, move AX, 1234H. The lower byte will be stored first and followed by the higher byte of data. So in this one, if we are accessing the data in the even memory locations, the processor need to give one cycle. So because our processor is a 16-bit processor, but until now the memory devices which we are using is having only 8 bits. It can store only 8 bits or 1 byte of data in one location. So this, out of the 16 bits of data which is supported by the processor, need to be stored in 2 consecutive memory locations like this. So now to select the data in the consecutive memory locations, to fetch the data from the even memory locations, then the processor need to access the data within 1 clock cycle. When we are considering the data which is present in the odd memory location, like to access this data, only this data in the odd memory location, the processor need to enter into this memory location and then it enters into this second memory location which is of odd memory location. So that's why processor needs more than 1 clock cycle to access the data which is present in the odd memory locations. That's why a processor is having to access the data at a time in like 1 clock cycle. This processor is dividing this particular memory 1 MB into odd bank and even bank. So here odd bank, which specifies the data transfer within the D8 to D15 data lines. Higher byte of data will be transferred using the odd memory bank, and in even memory bank, the data which is present, the lower data D7 to D0 to D7, this lower data will be passed using the even memory banks. So each of is having 8 bit. So when the odd bank will select and when the even bank is select, how can you say, how can the processor access the odd bank or even bank? How we can say? There is one table. So here it is nothing but the to read or write 8-bit of data, processor requires only one CPU cycle, no matter the data is stored in memory banks or not. But to access the 16 bits of data, the processor BIU unit requires one or more memory locations. To store the data, it needs to have 2 memory locations. To access the data, it may or may not, either it can use 1 cycle or 2 cycles, depends upon the data stored in memory location. So better to take the segment address as the even address. So if we are starting the even address, then it is easy to access the locations data present in the even address, and it requires only one clock cycle to access that particular data. So here, how to select, how processor gets to know that whole word is transferring, or the byte which is present, even address is transferring or odd address is transferring. So the pin bus high enable along with A0 address line, A0 pin, the combination of these two pins indicates the processor whether the data is 16-bit data has been transmitted, or 8 bits present in the upper byte or odd address is transferring, or the 8-bit present in the lower byte or even address is transferring. If the pins VHE and A0 is of 0 and 0, you can say that the whole data, 2 bytes of word, 2 bytes or the word is transferring simultaneously. Or if BHE is equals to 0 and A0 is equals to 1, you can say that the upper byte or the data present in the odd address, which is nothing but D15, D8 to D15, such of this byte is transferring. If BHE is equals to 1 and A0 is equals to 0, then you can say that lower byte of data or even address or the data present at D0 to D7 has been transmitting. So if both are ones, you can say that none of the operation is performing, the data is there itself. So this is how the physical memory organization has been in the 8086. Now, coming to other topic here, how to calculate the physical address or memory address, how processor, as I already told you, that the BIU unit is used to fetch the data and it will process this physical address calculation. How this physical address calculation will be calculated by the processor. So to calculate a physical address, there must be two data. One is segment address, which is present in respect to segments, code segment, data segment, extra segment or stack segment. Along with this segment address, it is necessary to have offset address, exact location, you can say that exact location. And this offset address, of where we can get this offset address? For some specified registers holds the offset address of particular segment registers. Like for code segment, the register IP holds the offset address. For data segment, the SI, DI, sometimes BX will holds the offset address. For extra segment, SI and DI holds the offset address. For stack segment, stack pointer and base pointer use it to hold the offset address. For these particular segments, these particular offset register, these particular registers only holds the offset address. So let us see how the processor will calculate the physical address for, let us see some questions. So here the question is the value of code segment. So here given data is that code segment register is holding the value 4042H. So given data. And the value of different offset is as follows. They have given BX value, they have given IP value, they have given the DI value. Destination in register, index registers, and BX base register, and IP instruction pointer. So here they are asking calculate effective address, which is nothing but memory address or effective address or physical address calculation. All are the memory address. So here 20-bit address. Memory location pointed by CS register. CS register is nothing but code segment register. Code segment register. Okay, we are having the segment address holding with the CS register. CS register is used to hold the segment address. Here they have given the segment address is 4042H5. So now you need to get the to calculate memory address, you need to have along with the segment address, you need to have offset address also. So for code segment, which register holds the offset address? As I previously said that for code segment, the register you use it to hold the offset address is nothing but IP. They have already given the value of IP here, 0580H. So now how to calculate the effective address or memory address? So to calculate the effective address, the formula is, or you can say that effective address is equals to segment address into 10H, or you can say that you can left shift the segment address 4 bits and add offset address. Add offset address. So here we have already know that segment address is 4042 into 10H and the offset address is used to hold with 0580H. So how much? 40420 plus 0580. So what is the value of effective address here? 8 plus 2 equals to A, which is a hexadecimal number. 5 plus 4, 9, 0, 4. This is the exact location where your data will be residing. So the effective address of the memory location pointed by CS register according to this data is 40980. Okay. Now coming to the second question. Here calculate the effective address for the following register. They have given the stack segment register, which is the segment address. Here SP and BP. As I already told you that to find the effective address of the data present at particularly in stack segment register, then you can, the offset address can be stored in SP and BP. Now, which register is used to hold this? Which register is used to find out the physical address or effective address? Here in this particular case, both SP and BP are holding the offset address of stack register. So, the address calculated with BP is taken as the offset given the starting address of the stack. So here offset address which is holded by the BP is taken as the starting address of the stack, and the offset address which is effective address which is calculated by the SP is denoting the particular memory location where the stack lies. So here you need to calculate two address locations, SS 3860 according to SP, or first we need to calculate the effective address for BP, then the stack segment 3860H into, which is multiplied by 10H, plus the offset address. Here we are using BP, so you need to consider 4826H. So which is nothing but 38600 followed by 424826, which is 6, 2, and here 14, which is nothing but E, 12, which is nothing but C, and 3. This is the effective address which is calculated by using BP. If you want to calculate the effective address using SP, then you can say that 3860 into 10H plus you need to take SP 1735H, right? So what will be the value? 38600 plus 1735, which is nothing but 5, 3, 13, So it is D93. So this is the effective address for stack segment using BP and using SP. Okay. So coming to the next question. Here they have already given that they provided the values of DS register, data segment, IP register, instruction pointer, BP and SP. But they asked us to calculate the effective address for memory location as per the DI register. Can we calculate the effective address for the DS register here? So to calculate the effective address, it is obvious that you need to have segment address. Here we are having segment address data segment, and plus we need to have offset address. So now the question arises, like which register is used to hold the offset address in accordance with the data segment. It is nothing but either SI, DI or even BX register. But these three values they didn't mention in the question itself. They didn't give the three values. So we can't calculate the value of effective address for DS because we are not having the offset address here. The register which is used to hold the offset address for data segment is either SI, DI, BX. But these three values they didn't mention in the question. So it is obvious that we cannot calculate this one. So now if the question arises like this, there is a chance to ask the question like this. Most of the cases where we are having the end exams, these type of questions will arise. So until now I have discussed about if they directly asked the data segment or else extra segment like that, stack segment. But if they mention this particular type of instructions, how we will calculate such type of instructions? So you try by yourself, or I'll explain after addressing modes, because here the instructions is having different types of addressing modes. So after the addressing modes concept, you will get to know how to calculate the physical address for this particular question. Okay. So until now we have discussed about the physical memory organization, physical memory, how 8086 physical memory has been divided like even and odd. So how processor will access these even and odd memory locations, when and where we are getting the total word or which higher byte or lower byte, and how to calculate the effective address or physical address. Okay. Thank you.